All right, let's take a look at these outliers. I think those are pretty easy to understand. It's any data that stands out from the other data, okay? More than two standard deviations of the residuals away. Okay, so because of that, it's really in this y direction because it's has more than two standard deviations of the residuals. Okay, so that then impacts some of what you think as an outlier. So let's take a look. This is our original data, so that's not our outlier. But take a look at this second one. Would you consider this unusual point an outlier? Okay, and because I believe that would be more than two standard deviations away from the other, yes, that would be. Okay, how about this one? Yes, again, also that one is way far away in the y direction, and those residuals has a really high residual, so that would be an outlier. But look at this one. This is where you need to understand maybe different from what you've been thinking. This is technically not considered an outlier, okay? Because it is in line with the rest of the data. So it's fine. I mean, it's not an outlier. So, nope. Now, this one, yes, again, way far out in that residual y direction, okay? So, question here, are outliers always influential points? And that is no, because if they do not have high leverage, then they may not affect the LSRL very much at all. And we saw that right here. Here is an outlier with very little impact on the LSRL. Very interesting. Okay. And then here, see, also notice that the unusual point in D, which I already mentioned to you, is not considered an outlier. Okay. I think we already know the outlier song, so I'm not going to go into that one because I want to now talk about this very important next thing. How does this leverage, okay, influential points and these outliers affect, specifically we're interested in how that correlation is affected and the slope. So we want to look at that. So for these, I have the graphs, the same ones as we have been seeing, but then I also have the numerical printout. So I went ahead and I did write the values of the correlation and the slope to 3 decimal places. I thought that might give us a little bit more detailed look at what's going on with the correlation and the slope. All right, so let's take a look. Here, this is the original data. So we can see our correlation, 0.987, very strong, and our slope, 0.887. Okay, so let's see what you think is happening. Here we go. So here we have this type of point. Would you consider it high leverage? And you can see that is no. Would you consider it influential? Is it changing the equation of the line? Nope, not very much change at all. Is it an outlier? Yes. Okay. Now, what happened to that correlation? Oh, so see, this outlier is reducing the correlation. Okay, so what happened to R? So I guess with all of these, I'm talking about what is that point doing to the data. So if I put that point in, what is it doing? It is decreasing the correlation, okay? Because removing it would increase the correlation to back up to 0.987. Keep that straight. Is this with the data in or removing it? Which way are you going? Okay. Next, how about that slope? Did that slope change much? 0.87, 0.887, not much. Not much change. Decreased a little bit, but not much. Okay. Next, let's see here. Oh, wow. Look, I can see definitely that slope just plummeted. That point made that slope plummet. So does this point have high leverage? Absolutely. Is it being influential? Definitely. And was it an outlier? Oh, yeah. So what happened to our correlation? Okay, so let's think of it this way. That point is reducing our correlation. Wow, down to 0.24. Okay, but what if I had asked you, like I am going to on the homework, what if you remove that point, what happens to the correlation? So if I remove this point, which is decreasing that correlation, then that will make it increase back up to 0.987. So removing that point will make it increase. The point itself makes the correlation decrease and the slope. That slope became much flatter and went down to 0.8187. All right. Now here, this is an interesting one. Right here, we have this situation where this point is out here and it's actually in line with the data. So does it have high leverage? Yes, it does. But was it being influential? No. And it's not an outlier either. Now, here is something that may not seem intuitive, but when I explain it, I think it'll make sense. Let's look at what that point is doing to the correlation. It is 0.993 with that point in. If you remember up here, it was 0.987, 0.99. That point made the correlation stronger. Why? Well, let's think about that. I think this will make sense to you when I explain it to you. Because this data point is farther out in the domain, okay? And it is a point that is in line with the data. Then what that is doing is that is saying, hey, people, I am confirmation that this linear pattern is continuing farther out in a larger domain. So, therefore, I am verifying a stronger linear relationship because I have a more domain of confirmation of that linear pattern. So that is why that point makes the correlation stronger. Interesting. So remember from homework, if I asked you, what does removing that point do? Removing this point would weaken the correlation a little. Now, how about the slope? Oh, I didn't write it in there. It stays the same. Okay, moving on. Here, this is interesting, okay? So this one back here, moderate. I think I put, it doesn't have high leverage, but it definitely has moderate leverage. It's got something going on there, okay? The next question, was it influential? I put slightly, yes, okay? Because we can see, and yes, it was an outlier in that Y direction, high residual. Okay. So what happened to the correlation? Okay, so that point, of course, being out of whack weakens that correlation. Look, 0.513. So definitely decreases that correlation. So removing this point, getting rid of that funky point would make that correlation go back strong. All right, so here's important. Let's think about this. Do you see how this point is to the left of the center? So it's going to pull that line up a little bit. This back end, it's going to pull it up towards it. So you can see that over here happening. So really that's making that slope a little flatter. So that is why that slope decreased. Okay? Because it made it pull up to the back end and it flattened it out some. Okay, very, very important. So now, again, when you go through your assignment that you were going to do, make sure that you know that on this page 50, I'm asking you to state what happens if the unusual point is removed. Now, there's one other thing that I want you to do. In our Canvas, there is a Desmos activity that I want you to click on. So if you click on, and they have all of the class periods here. So click on that activity and let me see what that loads here. Okay. So it will ask you, I think, to go in with your Google name or something. I don't know. This is an experience I haven't done before, but I had already kind of started this activity. And so you'll go in and you'll start the activity and it'll take you through 8 slides of where you can move things, and it'll ask you questions. And so here it asks you to describe the relationship. So you're talking about the correlation and such. So it's going to ask you to, has a little bit of free response things that you type in, but then it also has some things that you can move around. It has some points that they have changed, and they're asking you what happens. But what I really like is these ones at the end that you're going to get to explore and move these items around so you can see what's happening to the data when those points are being moved. Okay, so besides your lesson, your assignment that you're going to do, pages 49 to whatever that at 53, I think, then do this Desmos activity as well. All right, thank you very much. Have fun with that Desmos activity.